Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in the last lecture we have studied about the methods of preparation of benzene, as well as we have got to know that what is the mechanism of the electrophilic substitution of benzene. And now based on that only we are going to study about what are the reactions that are being showcased by benzene. So let us talk about that. So in this topic we are going to discuss about the few reactions that are being observed by the benzene, and what are those reactions. Let us talk about that. So starting with the first one, that is chlorine. The second is addition of hydrogen molecule. The next is addition of ozone, and the fourth is halogenation process. The fifth is sulfonation process, and the sixth is nitration. So these are the six reactions that are being usually observed, or the reactions are being done by the benzene, and that is the thing that we are going to talk about. There are basically six reactions that we are going to talk about, and there are also a separate reaction, that is Friedel-Crafts reaction, but that is the reaction that we will take on the next lecture. And talking about this thing, we have included here 3 addition reactions while 3 substitution reactions. So addition reaction is the one that is been not showcased by benzene in a normal condition, but for that we have to provide a critical condition, or we have to provide some of the conditions on which basically benzene will undergo an addition process. So these 3 are basically the addition reaction that I am going to talk about, and the next thing is the substitution. So starting with that, we'll talk about halogenation process, sulfonation process, and nitration process, and that also in a deep detail. So let us talk about the first one, that is what will happen if the addition of chlorine will take place on the benzene. So this is the reaction that are being shown by the benzene also, if we have included chlorine in that. So let us talk about that. So starting with the first one, that is so what we have to do is we have to do the addition of chlorine gas, and suppose in this case, according to the Kekulé structure that we know, it could be written as in this form. And since it consists of the carbon-carbon double bond, and we know that basically they are very much stable, and that's the reason the addition reaction don't takes place, but meanwhile the substitution reaction takes place. So in this case, suppose if it is in benzene, and if we have included that is chlorine gas, or 1 mole of chlorine. So what will happen, suppose if it has to undergo the addition process. So this is not the normal condition that we have to provide. We have to provide some condition which involves UV light, and because of the UV light only, the addition process would take place over here. And since suppose if I have included only one Cl2 molecule, then what will be the possibility is only one bond would be broken into carbon-carbon single bond, and the Cl atom would be attached over here. But as I could see, because there are basically 3 carbon-carbon double bond over here, so that's the reason that we have to involve, that is 3 moles of Cl2 molecule, making it to be known as, that is 6 moles of the Cl atom. So that is the reason that the addition reaction would take place in such a manner that every carbon atom would attain 1 chlorine atom, and every carbon atom has itself a hydrogen atom that is attached over here. But this is the representation of the benzene that we have did. So in this case, what we will get to know, that we will get a benzene ring. So there is no conjugated system over here, because the benzene ring is now undergoing addition process, and that's the reason that we could see that each carbon atom consists of a hydrogen atom as well as the chlorine atom over here. So this is the structure that we have got, and this is only possible if the reaction, or if the benzene has undergone an addition reaction of chlorine, and the product that has been formed is because of the addition reaction on benzene. That's the reason the name of this could be called as BHC, or we could call it as benzene hexachloride. Simple. So this is the product that has been formed, but the condition is different. It is not just like the halogenation process, but it is different process in which you could see that it is an addition reaction, and in halogenation process, obviously that is called to be a substitution reaction. So we are going to talk about the halogenation process later on, but for an instant we are going to move on to the next one, that is what would be the addition of that is hydrogen molecule. So the next is what we are going to do is that is addition of hydrogen gas or addition of hydrogen molecule. So again we are making a reaction of benzene with hydrogen, so therefore I am drawing a structure of benzene over here. And again it is very similar to that of the that is reduction of alkene and a reduction of alkyne, in which the hydrogen is being required. So therefore in this case I am including, suppose, a hydrogen molecule, but obviously you know that the hydrogen that is the hydrogen process doesn't take place by its own. We have to involve few catalysts also. So therefore in this case what we are going to do is we are involving rare nickel, or we could say as nickel, and that also in a particular temperature, and that particular temperature is could be heat, and that temperature would be basically 458 Kelvin or 473 Kelvin, depending on the condition that we have. And in this case basically the addition reaction would take place, but there is not only one that is carbon-carbon double bond. There are basically 3 carbon-carbon double bonds, so making this to have included 3 moles of H2. So ultimately we have 6 hydrogen atoms, and that's the reason that we could see that all the double bond atoms that have been present over here will now be substituted by the hydrogen atom. So that is the reason that it had already an hydrogen atom over here, and that's the reason that if we include that is, if I would write in this way, that is, if hydrogen is present over here at each carbon atom, that is in this way. So the product will also, because it is an addition reaction, so that is the thing that nothing substitute, so no hydrogen would be substituted over here, only the hydrogen that are being already present, they would stay as it is. Meanwhile, the hydrogens that are being added, even they would be on the carbon atom. So here I would write it as hydrogen that are being included after the addition process. So this is basically a product that where we have got, or where we have destroyed the double bond into a carbon-carbon single bond, and that is the reason the thing that we have obtained over here is basically a cyclohexane. So therefore the name of this one can be written as cyclohexane. And let me tell you one thing, because when we are talking about addition reaction of that is in alkene or alkyne, basically even the reaction would take place without the presence of the catalyst. Even the reaction would take place, but still when we are talking about the benzene, we have to provide certain catalyst, and because of that catalyst only the reaction would occur, and that's the reason it is very difficult for us to understand that the addition reaction of the benzene doesn't take place by its own, but we have to provide certain conditions for that. That is the reason addition reaction doesn't take place very readily or very easily when it comes to the reaction of benzene, and that is the reason that we have to include a catalyst. So this is the thing that we have got, that is a cyclohexane. And now let us talk about the another addition process, that is ozone, addition of ozone. So let us talk about that also. So now we are going to do a reaction that is addition of ozone. So addition of ozone should be done on benzene, and this is the process, or this ozonolysis that we are talking about. This is the process that we have did in the chapter that is alkene as well as alkyne, and in that case also we have got a product by the hydrolysis of the ozonide that was being formed as an intermediate in the reaction. So similarly to that, even this case also we are going to talk about the addition of ozone on benzene. So let us talk about that. So this includes, basically we have to involve a benzene in the reaction along with that of the ozone, that is O3, and the reaction should proceed in such a manner, or that it should be there should be an involvement of basically an organic solvent. And basically benzene is called to be an organic solvent itself because it is being used in as an organic solvent also. So now suppose if the ozone analysis takes place over here, and we know that one ozone molecule is being capable for that is forming an ozonoid on that is one carbon-carbon double bond. But there are not only one carbon-carbon double bond, there are basically three carbon-carbon double bonds. So that's the reason that we have to include 3 moles of ozone or just to balance the reaction. So now the ozonolysis would take place in such a manner that we could see that this double bond will be involved in the formation of an ozonoid. So therefore this double bond would break in such a manner that we could see the oxygen which has been involved between these two carbon atoms, and that's the reason that we could also see this oxygen that would be on this section. And meanwhile this is a carbon-carbon single bond, so nothing will affect on this one. And talking about the another one, that this is again a carbon-carbon double bond, so therefore we could see that is being an ozonoid is been formed in this case. So therefore I'm drawing in such a manner so that you could understand. And talking about this carbon is a carbon-carbon single bond, so therefore there will be no effect on this. So I would write it over here like this way. But meanwhile this is a carbon-carbon double bond, so therefore there would be an involvement of an oxygen atom over here between this two carbon atom, and that is the reason. And again an ozonoid structure would be formed over this carbon-carbon double bond, so that is what we have drawn over here in this way. But meanwhile, if we are talking about this carbon atom, then this carbon is carbon-carbon single atom that we have got. So this is the structure that we have got, and this is basically known as benzene. Benzene, that is ozonoid. So therefore, it is a kind of ozonoid that we have got. So this is not the stable one, or this is not the product that we will get. So again, the thing that we have to do is we have to do a hydrolysis in presence of zinc. So the thing that you have observed is the double bond is now been converted into an ozonoid everywhere. So this is the same thing that we have did in that is in ozonolysis of alkene. So this is what we have got. So the thing that we have to do is we have to convert this ozonoid to a particular aldehyde or ketone, whatever it will get. So we have to do basically the hydrolysis process. So we are doing that now. So we could write it in this form, that is just for an reference we could take in this way also. So this is the benzene ozonoid that we have got, but the reaction is not over yet. We have to do the reaction in presence of zinc and in water. So now the zinc would be able to successfully remove this oxygen, while the hydrolysis process will try to break this bond over here. As you could see that if oxygen has been removed from this area, then we could see that the only thing that would be remain is this carbon atom and this oxygen for a while, if you would understand this one. So this would be obtained. So we see the product that will obtain is basically it consists of two carbon atoms that are being assigned to each other. Along with the hydrogen atoms will also be involved in that process, and the thing is this would be basically, I would write it in this form, that is here it is hydrogen that is been involved, and here also the hydrogen atom is been involved over here. So therefore the hydrogen atoms would be involved over here in this manner, and this oxygen would be turned into basically an aldehyde group or a carbonyl group, as you could see. So that this group has been formed by only the formation of one hydrolysis, but yes, there are different carbon atoms are also been involved, and because of which the hydrolysis process will take place for every carbon-carbon atom, and that's the reason that we could see even the hydrolysis would take place on, that is this section, and again on we could say for this section. So that is the reason we will get basically 3 moles of this glyoxal. And since zinc is being capable of removing this oxygen that has been in the blue line that I have been drawn over here, so therefore the zinc will be removed as ZNO. And this process, the zinc has been used because of which it is acting like a that is a reducing agent, and it will try to remove the oxygen. So this is what we have got as a glyoxal, and 3 moles of glyoxal is what we will get after the ozonolysis of the benzene ozonoid. So this was an involvement of the addition reaction that I was talking about. So it was very much easy. So now let us talk about the another one, that is what is halogenation process. So this topic, that is we are going to talk about halogenation process. And halogenesis process is involvement of either chlorine, either bromine, or either iodine. So now we are, especially we are talking about for them separately. We are going to talk about that is for chlorination and for that is bromination. So let us start about with the first one, that is chlorination. So this is basically a substitution reaction that I am going to talk about, and in this case, the benzene has been involved along with that of the chlorine. So this is benzene that consists of basically 6 hydrogen atoms, as you could see over here, and we are doing a process known as chlorination. That means there should be an involvement of chlorine gas, so therefore I will include chlorine gas, and that could be represented in this manner. But the reaction doesn't take place in UV condition, because if we involve UV condition, or then the product that will be formed is that's BHC, that is benzene hexachloride. But the condition here, because we are talking about chlorination or halogenation, this is a substitution reaction. That is the reason we will be including the base like this one, that is AlCl3, that is anhydrous AlCl3, or a nucleophile that would turn into a nucleophile if the substitution reaction would take place. And this kind of substitution is basically electrophilic substitution. That means that this AlCl3 will be very much beneficial for us to take this Cl with it, so as to form Cl plus atom, and so as to form Cl plus ion, and that will turn into basically an electrophile, and that's the reason that electrophilic addition would take place by removal of one hydrogen, that is deprotonation will also happen in that case. So therefore in this process basically what happens is, I will write over here, this AlCl3 when it's involved with Cl2, so therefore what happens is this will internally make one of the Cl atom to be positive, and meanwhile what we will get is we'll get a complex just like the AlCl4 minus, and that is the thing along with that of the Cl plus ion. And now this Cl plus ion is acting like an electrophile, while this one is acting like a nucleophile. So therefore this one would be able to remove one of the hydrogen atom from the benzene, and that's the reason that we could get basically a substitution reaction. And the product that would be formed in this case is basically where the carbon-carbon double bond will remain the same, because the substitution reaction takes place by the removal of hydrogen. So now in this case basically, if the Cl atom that is going to substitute on the one of the hydrogen atom, and that will remove one of the hydrogen atom from there, and we could see that one Cl, that is this Cl minus this. Can you show the topic? So in this case basically the Cl plus that is acting like an electrophile that will substitute on the one of the hydrogen atom, and in this case one hydrogen atom would be removed in the form of H plus, that is in the form of proton, and that will take away by this nucleophile. So what will happen with this nucleophile I will tell you later on, but what will happen is this Cl plus, that is the electrophile, that will substitute on any one of the hydrogen atom, and that's the reason that we could write the hydrogen atom would be replaced in this case, so therefore the Cl atom would be over here. So now this is basically the chlorobenzene that we have got. While the hydrogen atom that was being replaced here, and there are actually the hydrogen atoms also here, but I have not represented it, but this hydrogen would be replaced by the chlorine atom, and that would be taken away by the nucleophile. And while talking about this nucleophile is nothing but AlCl4 minus. So in this case basically what will happen, the hydrogen atom that was being removed, or for which it was being replaced by the Cl plus among this, suppose if I am talking about this one as Cl plus, so that was being replaced on that hydrogen atom, and we could see that the remaining Cl minus is now being replaced with and now we could see that the remaining Cl minus, or we could see the nucleophile that has been converted into nucleophile, that is AlCl4 minus, that will be here, and that will take away the H plus atom that has been removed from the benzene, and that's the reason it will form basically again AlCl3 plus HCl. So in this case what we have got to know, we have got that AlCl3 is the thing that is been retained, and that's the reason it has been acting like a catalyst here. And the remaining part that would be eliminated from the overall process is basically HCl. So this is the reaction which happens when a benzene is being reacted with chlorine molecule and in presence of an anhydrous AlCl3 so as to form chlorobenzene as well as a byproduct as HCl. While in this case basically AlCl3 will be reacted with the chlorine molecule so as to form a nucleophile and an electrophile, and this electrophile will go on substitute towards the one of the hydrogen atom, and that hydrogen atom that has been removed, that would be basically reacted with AlCl4 so as to form AlCl3 again, and by the formation of HCl. So this is the overall reaction that was been happening in the chlorination process. So now let us talk about the another kind of the halogenation, that is bromination process. So again, this bromination is also a kind of halogenation process, and in which the bromine molecule would be used instead of that of the chlorine molecule that we have talked about. So the catalyst also required in this case would be different. So in this case, suppose if I am representing benzene, which consists of basically 6 hydrogen atoms, as you could see over here, and for which I am including that is bromine molecule. So therefore bromine molecule can be written as in this manner. But it is not that we have to use anhydrous AlCl3. In this case, the catalyst or the reagent that we are going to use is basically FeBr3. So it will be similar to that of the chlorination process, in which basically the FeBr3 it will be reacted with that is Br2 so as to form a nucleophile, and that nucleophile is nothing but FeBr4 minus plus that is Br plus. And in this case, basically the Br plus ion is acting like an electrophile, and that is the reason that this electrophile will replace this hydrogen atom so as to form bromobenzene. And that's the reason that this hydrogen atom would be removed, as we could say. It is not only this hydrogen atom, any one of the hydrogen could be removed, and that hydrogen would be reacted with again FeBr4. And similarly to that, suppose if that hydrogen atom, that is H plus atom that has been removed, that will be reacted with FeBr4 minus so as to produce that is FeBr3 plus HBr. So again, that is the FeBr3 is being retained, and that is the reason that it has been acting like a catalyst, and the thing that has been removed in this case is basically hydrogen and Br, that is hydrogen bromide. So this was basically the reaction in which we have converted benzene into bromobenzene. So this is how the reaction happens, and that is the reason the conditions are also very essential for us to maintain the process, and that is the reason that we are seeing the substitution reaction, that is it is different for chlorination and it is different for bromination, and the catalysts are also playing a very vital role in this case. So this was a kind of mechanism also that I have maintained to show you, and that is the reason that we have got over here the information that we could convert benzene into bromobenzene. But it is not only that we can replace only one hydrogen, we could replace all the hydrogen atoms that are in benzene. So that is the reason that we have to use 6 moles of Br, and that is the reason again the same catalyst should be used so as to get a hexabromo benzene. Similarly, we can convert a benzene into chlorobenzene or hexachlorobenzene by using that is 6 moles of chlorine molecule, that also in presence of anhydrous AlCl3 by formation of 6 moles of HCl as a byproduct. So it was very simple process. So this were the two process of halogenation, that is chlorination and bromination. And talking about the iodination process, so now let me talk about iodination process. Even iodination process is a kind of an halogenation process, in which what is the mentioning thing is the hydrogen atom of the benzene, it would be replaced by the iodine atom by using that is I2 molecule. So suppose if I am taking a benzene, and for which if I am reacting it with iodine molecule, But it has been found that this kind of process or this kind of iodination process is actually reversible. So that is the thing, that we could form basically an iodobenzene by replacing the hydrogen with the iodine. So that is, this would be removed as Hi eventually, and similarly it happens with the chlorine molecules also. Suppose if chlorine atom are present, so therefore HCl will be removed, and that is the reason this will attack on the carbon atom so as to form a chlorobenzene, bromobenzene, depending on that. So this is the reaction that we could get in iodobenzene during the formation of iodobenzene, but the reaction is reversible. So that is the thing, that if that is iodobenzene is now again reacted with Hi, then again this kind of reactant would be produced. So basically the iodobenzene or the iodination is not a valid thing for to obtain basically iodobenzene. So that is the thing, that we don't prefer iodination, we prefer basically chlorination or bromination. So this were related to the halogenation. And talking about the next one that we have, now we have talked about the 4 processes or the 4 reactions of the main reactions of the benzene, and now let us move on to the next one, that is nitration. So now let me talk about nitration process. Nitration process is nothing but involvement of a nitric acid, a mixture, or we could call it as a nitrating mixture. That is nothing but the composition of the mixture of nitric acid along with that of sulfuric acid. So that mixture is been included with the benzene, and in that case what we could see that the hydrogen atom is been now replaced by NO2 group, and that kind of process is basically known as nitration process. So let me give you an example, and let me show you that how the reaction proceeds. So for example, if I consider benzene, which consists of the hydrogen atoms, as you know that it consists of 6 hydrogen atoms, and for which we have to make the reaction in such a medium that it consists of nitric acid along with that of that is sulfuric acid. So the nitric acid can be written in this form, that is HONO2, and that also in presence of sulfuric acid, that is H2SO4. So the overall reaction would take place in such a manner that this OH, or this hydroxyl group that we have, that will be able to remove this hydrogen atom so as to form H2O as a byproduct, and meanwhile the NO2 group that will be attached or that will be replaced in the hydrogen atom over here. So one hydrogen atom would be replaced in this case, so basically we could get a nitrobenzene. But let me show you the mechanism, that how the mechanism works, or how this reaction actually works. So for that I'm keeping this aside, so as we will recall this later on. But meanwhile, that is HNO2, if I would write that is nitric acid in this form, that is HNO2, and I am representing the H2SO4 that has been involved in this case. Is basically I will use 2 moles of H2SO4. So this process, what will happen is the NO2 plus ions will be produced, that is along with that of the other molecules, that is groups like H3O plus, and that is 2 moles of HSO4 minus. So now in this case, the one which acts like an electrophile is basically NO2 plus, and in this case, because of which that we have used H2SO4, now sulfuric acid plays a very vital role in the formation of the electrophile, that is nothing but NO2 plus. So now that is the reason that NO2 plus is basically the electrophile that would be very much essential so as to replace the hydrogen atom, and that is the reason that we could get in this case, that is we would get the hydrogen atom that would be replaced by that is NO2 group. And meanwhile the NO2 group has been replaced the hydrogen atom, and meanwhile the hydrogen atom along with this OH that will be removed as water. So now the condition that we have maintained here is basically acidic condition, and that's the reason that we have taken a nitrating mixture, that is the involvement of nitric acid along with that is with H2SO4, that is sulfuric acid. So this is the reaction that occurs in this way, and the formation of that is nitrobenzene takes place. And moreover, if we could see that because of the H2SO4 that is been involved, and that's the reason that H2SO4 is also known as dehydrating agent. So in this process, basically the dehydration has taken place by the removal of the H2O, and this is not a reversible process because H2O has been removed, and that's the reason that we could easily convert basically a benzene to nitrobenzene. So that is what I wanted to explain about the nitration process, and that is the thing that I wanted to explain you. So now let us move on to the next one, that is sulfonation process. So now we are talking about sulfonation process. So as the name suggests, that sulfonation means including of a sulfuric acid in the on benzene so as to remove the hydrogen atom and to replace a particular group of sulfuric acid. So now let me explain this reaction. So the thing that we have to do is here I have represented benzene, and for which if I am including that is sulfuric acid, and the sulfuric acid could be written as in this way, that is HOSO3H. And in this case, the thing that we have to apply is we have to do this reaction in fuming condition, that is in fuming condition of I would write it in this way, that is fuming sulfuric acid or fuming H2SO4, and that also with a particular temperature around something around 100 degrees Celsius, or I could write it as 373 Kelvin. So in this particular condition, what will happen is obviously that we are providing heat, and that also 100 degrees Celsius. So obviously because of the H2SO4, which is nothing known as the dehydrating agent, so that would be able to remove this H and OH as water. So now the only thing that is been left with us is basically a benzene ring along with that of the SO3H. So now this is the benzene ring that we have, and along with that of the SO3H. So this is what we have converted, basically a benzene into benzene sulfonic acid. So this was the reaction of the sulfonation that I wanted to explain, and that's the reason that it would happen in this manner. And talking about the overall processes, and talking about basically that is an addition process. The addition process should occur in basically in a certain conditions, and now talking about basically the substitution reaction, and especially about the electrophilic substitution reaction. Then we have got to know that in chlorination, basically the Cl plus is basically the electrophile that is been acting, and in bromination Br plus is the one that is been acting like a electrophile. And talking about in nitration process, NO2 plus is been acting like a electrophile. And with respect to that, we have got to know that that is anhydrous AlCl3 which forms basically along with that of the Cl minus has to form AlCl4 that acts like a nucleophile, and similar to that of the FeBr4 minus, again it acts like a nucleophile, and we know that HSO4 minus is also acting like a nucleophile. So in this process we have got to know even these things so as to make us understand that how the mechanism of the reaction is basically for the substitution reaction. And now this is how we have made a sulfonation reaction. So this is the overall reaction that I wanted to explain you. So thank you friends for watching this video. I hope you have understood this video very clearly, and you'll share this video with your friends. So don't forget to subscribe to Ekeeda channel. Thank you so much.